record. Um, I don't know if I've shared my screen yet. I haven't, have I?
Oh, not yet.
Not yet, okay. In that case, let's do that. Okay. So yesterday we were talking about fact tables and um, dimension tables. We spent quite a long time on that. So I decided to put a few things together around the data modeling for us to get a better hang, of things. Um, I added a few slides to this dear slide of mine, and we are going to quickly go through it. We are going to quickly go through this. So why are we discussing data modeling? Uh, because it's an important part to our work as data analysts or data professionals. You know, after you got your data, you've cleaned it, you've done every necessary work on making the data usable. If you are working with a, a data set that's more than one table, and usually you would be working with data sets that's more than one table. You have many different tables of data that you are working with. So you want to look at how you um, create relationships between them so that they can operate well, more like talk to each other in the way that you need them to talk to each other. So you are the one that's manipulating that process, and you are going by the problem that you want to solve. That is what would inform what you are doing all through the process, you know. So data modeling in data warehousing uh, and business intelligence world, which is what we are currently doing. We'll talk about fact tables and dimension tables because these are the two essentials, the essential components of your data model. And we have established yesterday that fact tables frequently store quantitative data for analysis. They normally record events that may or may not include measures, and they must record these events at the lowest level of granularity. And what that means is that sometimes a business does not necessarily deal with numbers. It could be interactions that you are measuring. An example would be NHS data. Maybe you are just measuring the number of appointments, um, that's the people that come through to the surgery, for their appointments. That's the event that your business is about. Or in education, you are you are looking at interactions within the school, students' records, and things like that. That may or may not necessarily involve quantitative measures, but it will still be a fact table. And that's because it's recording the events that are happening within that business. And uh, when we say lowest level of granularity, it's always best to capture your data um, at the lowest level of information that there is. For example, um, in a store, if you are recording orders by month, rather than breaking it down into recording it by maybe by seconds, by by hours, by minutes, by day, you know. So if you roll it up to recording it from the level of months, so if all your data set has got is January, February, March, that's each row, you know, is the whole month. That's not always, it doesn't always give you a good, a very good uh, insight into what is happening within that uh, within that business, you know, because the lowest you can see is what has happened at the month level, you know. But unlike if you had captured maybe every day or even every hour or every minute or every second, it's always really good to capture from the lowest level. In terms of time, we are looking at if you can capture by second or by minute or by hour, then all of those can be rolled up to look at what is happening in a day, then what is happening in a month, and then what is happening in a year, you know. So that's always the best way that we should capture fact data. And then dimension tables, you know, uh, like we said again, like we established yesterday, we say that these store descriptive information or attributes, which can be used to filter and group the data, the measures we got here from the fact table. You know, we say that it defines how a fact should be rolled up. Are we looking at maybe total number of people that visit our gym? Are we looking at it by month or by customer? How many visits per customer? Or are we looking at things by geography? You know, um, how many visits do we have in Luton or in the Bedfordshire area? Or are we even combining these measures? We can say in by month, how many uh, visits do we have by month and by customer, you know, to our gym in the Luton area, um, you know, so that's what all of that is about. So we keep repeating these bits because these two, when we get those two straight and right, they are the foundation on which data model or data modeling uh, hang on, you know. And then we move on to the concepts of primary key and foreign key. So primary keys, they are the unique identifiers. So they are normally unique and they are found in dimension records. Um, whereas foreign key are what establish a relationship between two tables by referring to uh, a table with common column. And we saw examples of that yesterday. I believe we'll see more of that today again as well. When we are talking about data modeling, the things you want to consider things like what am I measuring? You know, in order to build a good data model, what am I measuring? What type of business problem am I solving? All of these two, I believe you would have gotten from your business requirements anyway. Then you will look at how much data am I working with and what are my data sources, you know. So those are the things you want to consider. And then what are the attributes of a good data model? Your data model it should be easily understood. When somebody sees the model, they should easily understand it. Not that everything is just like scattered here and there, you know. Uh, it should be scalable. And what that means is that, you know, because when you build a data model afresh, like anew, chances are that it would grow with time. So when there is change in data or when there is an update to your data source, those changes should not really affect your data model. Your data model should be able to contain the changes as they come in. That's what that is about. Provides predictable performance. The way you model your data should enforce a good performance within your data model, within your data set, and within your report. It should be flexible, it should be adaptable, but not at the expense of being well understood. It's not good for you to go into your report and you're trying to explain to somebody what you have done, and even you are confused because of how everything is arranged, within that model. So it's good to work on this and um, have have some documentation in place. Some works I did, which the reports I'm building today, I just sort of built some um, diagrams to show me all the tables that I've got, their sources and which table is relating to what within my model. So I've got a document backing that work up so that if I'm reading it, if I get confused about anything in the future, I will refer to that document. And if someone else needs to pick it up, when they see that document, they would easily understand. It's also part of your business templates. It should be part of that package as well. Am I still in class? Sorry, I've been talking and talking. I just want to get through this and then we can quickly build a model ourselves from that Excel. Up to now, is it making sense? Am I still here?
Yes. Yes.
Okay, thank you. Um, what is easier with a good data model? Uh, when there is a good data model, uh, storage constraints is well managed. I think it's just a repetition of what we saw before. Performance tuning is well done. When you have row level security in place, it is well managed. And when you are writing your DAX, if you are working with Power BI depends, your DAX rather, depends a whole lot on your data model. That's when the data model is well done, writing your DAX becomes easy, you know. Now then we go into the different types of relationships or well, not necessarily relationships, different types of data models that we have. The first one and the simplest one, the one that we always aim for when we are building a report afresh from scratch, is called star schema. And it looks like this, a star schema, where you have the fact table in the middle, and then you have the dimension tables surrounding it to look like something like a star. In the middle here, we have a member diagnosis. So this information here is a hospital information. So the fact table, which is the fact table, many because one person's information could appear here many times maybe because they visited the surgery at different times and those different times have been captured, so that information, most of the information here are many. So we say facts table is the many side of the relationship, and the dimensions that are beside are the one. If this is, for example, if this is a patient information now table, each patient would appear here once. If we are looking at a screening center, each screening center would appear on this table once. Whereas on the many table, each screening center can appear many times. That's why we use the language many and one when it comes to fact tables and dimension tables, when we have built our data model. In the concept of data model, fact table becomes many because information there is captured many times, whereas the dimension tables are the one side of the relationship because the information, each row is unique, okay, in the dimension table. So the star schema, these are the properties. Fact table is in the middle and it is surrounded by dimension tables. It looks like a star, and fact table is the many side of the one-to-many relationship. So that's the star schema for you. And then we look at the snowflake. That's another type of data model. The snowflake, it's got elements of the star schema, but there's a bit of branching out with our dimension table. Can you see that this bit ignore or cover up this side that says flake? If you look at this fact table, this dimension, dim is just for dimension. Dimension, dimension, dimension. If we consider just this side of the relationship, that forms a star schema. But when we start having a bit of branch happening to our dimension, for example, look at the dimension screening center. It's got a table attached to it. So there's a branch, like a flake, is flaked out for us to have a dimension geography now. So when we have that, it's no longer a simple star schema. It is now a snowflake schema. Most of the time, this example is not so obvious. You could have branching out branches on all of the tables, and even this branch itself could have an extra branch such that it doesn't look, it starts to look complex. You know, it doesn't look as simple as what we saw here anymore. You know, so when that starts happening, then that schema or that data model is called a snow schema, and these are the properties of it. The center of it is star schema. Yeah, we have that here. Like fact table in the middle, like we had before. It's also surrounded by dimension tables. Then dimension snowflakes of dimensions snowflake of other dimensions. So like this dimension table is flaking off this dimension table. That's the major difference, or the only difference actually, you know, between the star schema and the snowflake schema. Fact table is the many side of the one-to-many relationship like we had before. Is there any question about these data models that we have just been introduced into? I think when we start to use it and form our own relationships, we will understand it better. But is there any misconception that you want me to address before we move on? No? Okay, I'll move on. And then we'll
I
talk.
think Irene raised up her hand.
Oh,
Um,
somebody's hand is, please talk.
All right, ma. Yeah, just a clarification.
Yeah.
Formerly before now, when I was growing, I used to see modeling as formulas, like you are seeing formulas, working with formulas. But with data modeling, I just want to clarify, is it just building relationship or you still need to apply formulas when you are doing data modeling? That's my question.
No, it is just building relationships.
Okay, thank you.
Yes, when you then start to use it within your report, you would write formulas. But at this point, we are just building relationships.
Thank you.
You're welcome. And then relationships, well, we've been talking about relationship. It's just like what we have in the human world, you know, relationship between friends, you know, relationship between husband and wife, and different types of relationship, you know. And in relationships, there must be communication. When there is no communication, there's no relationship. Okay. And that's what these tables are doing when we are saying they have relationship, you know, with one another. They are communicating, you know, with one another. So what's the relationship in data model? Connection between two tables. Connection between two tables. And these are the connections, you know, that we can see when event is able to relate with date, and that relationship is happening because we've got date table here, full date. So there's a column here. These are the columns, by the way. So the whole of this square or rectangle is a table, and everything we see inside of it is the columns that we see within a table, okay? So we can see here there's a column called full date, and we see a date here as well. So because there's a date column here and there's a date column on this date table, those two can relate, okay? And we see there's a 1 written at the side of this, and there's a star written at the side of the fact table. Events is the fact table. Members is the dimension table, and date is also a dimensions table, okay? The dates on here, on the date table, each date appear just once, and that's why it's the one side of the relationship. Whereas those dates can appear many times here. On the same date, many events could have been recorded within this table because it's the fact table. And that is why this side is the many side of the relationship. The same goes for members and events. Between members and events, we have 1 written here and star. The star stands for many, by the way, written on the events. So on this members table, each member's record is recorded once. So you find each member's record once. So 1 row represents a member. That same member will not be repeated within this table. So that's why this table is the 1 table or the dimension table, okay? And if we look through, let us look through a quick classwork. Can we see, I can read this well. Can we also read this well? The columns, the names of the columns within the members table. Are you able to read it well? Because we are going to look for, we can, okay. So let's look for which column is common to both members and events. I want to see which column they are building this relationship on. I think I found it. Anybody found it yet?
Yeah, member unique ID.
Thank you. Member unique ID. Member unique ID is on this table, and that same member unique ID is right here. So that's why these two can have a relationship. And this type of relationship is a one-to-many. One, that is one side of the relationship, to many side of the relationship. Many because this member, one member here can appear like 10 times if they have visited and their events have been recorded 10 times. So that's why there are many. So the types of relationship that we have, one-to-many, we can have one-to-one, and we can have many-to-many. Now, the best type of relationship to form for good performance within your data report is the one-to-many or many-to-one. One-to-many or many-to-one. That's what we always aim for. A few times you might not get that, but if you get that, like what, 90% of the time, if you aim for it and that's what you get, then you'll be sure that your work will be made easy as you carry on with your analysis. And that's why each process is very important. If you had cleaned your data well and arranged your tables well, ensured that, for example, within the date table, you are not having duplicates. Within the members table, you are not having duplicates. If all of those are well ironed out, when you get to this point, then it will be easy for the tables to find themselves in the one-to-many or many-to-one relationship. Any question? Any question at all? If there's no question, within just 2-3 minutes, I don't think we can be able to do that anymore. I was just going to quickly get us to build like a skeleton. It's called conceptual data model. A quick skeleton of how, if we are given like this table to work on, this is our fact table because orders are recorded here. So it's the fact table. Say this is the only table you are given to work with, and you have to build your data model. Now it becomes your job to look for the dimensions. Also, it depends on the question they're asking you. You know, if they're asking you to find the measures by customer or by employees or whatever. Let's say they haven't given us, they want all the dimensions within this data set to be able to, they want us to be able to, you know, filter our measures that we are going to do by all the dimensions within this table. Now, the first step is you want to identify which of these columns would go for dimension. Which of them would be your different dimension tables. Okay. For example, I see customer ID. So that tells me that there will be I should have a customer table as one of my dimensions. Okay. Is there any other thing that we see here? Because we are about to quickly, let me go to insert. I think there's smart art here. Yes, there's smart art. So if we go to cycle and we can choose this. So I'm just choosing that to quickly show us this is something you can do with your pen and paper, by the way. It's just nice to see it like this. So in the middle, we've established it from our relationship data models that the fact table is always in the middle. So our fact table is going to be here. And what's the name of our fact table on here? Going by the name here, what name should we give our fact table?
Orders table.
Orders. Okay, so I'm going to quickly put orders here. Okay. Then I did say that customer ID is here. So customer is one of my dimension that I'm going to use. So it's one of the dimension tables that would surround it is customer. Okay. Let someone else give us another dimension that we could get from this table.
Employee.
Employee. Thank you. Okay. Which other one?
They are definitely ordering something. So they are definitely ordering a product. So a product is another dimension.
Okay. Yeah, I don't see
So
the
that
product.
order is based on a product. They are
Yeah,
ordering
it
a
is.
product.
It is. And I was expecting to see a product ID here somewhere. I don't know why it's not there. Because you remember I hid some table. It's not there, but it's actually part of what we are going to be needing. If I unhide, so product is there. Thank you. What else? Please, let's talk. I want to ensure that we get it.
What about date table?
Thank you. Date is also one of them. Yes. What else? Let me
The
scroll.
location where the orders were made.
Yes. Because we got country, postcode, region, and all of that. Okay. So should we just call it location for now? Yeah. Okay, I forgot that it is interesting what is happening with this Okay, let's come back
You want to add
here.
more, right?
Yeah, I should press enter, but you see my enter button, only God knows what happened to it. I don't know how to restore it yet. So I had to opt for this on-screen keyboard. Right, so what else can we see? We've categorized all of these as location for now. Is there any other thing
We want
that
to
you see?
know who shipped those orders.
Yes. So
So shipper, or what do you call it?
yeah, it will be
Uh,
shipper. So let's go for shipper. I hope that's spelling is right. Okay. Is that all? I'm not sure we see got more, but it looks like we've captured most of it. It looks to me like that's all. So we got the product which is not here, but it's actually there somewhere. Okay, because like Bertoli said, something was actually ordered. And that's it really. So when you do this, it gives you a good idea of how your data model should look like. So you have a skeleton of it, okay? And by the time you then take your data into whichever of the tools, either Excel or Power BI that you're going to be using, you have a good idea of what you are working with. The job becomes very easy there. So if you are not getting a good data model yet, you can always look at what you are not doing right and write it before you move forward. So this is in our data model that we've just drawn the skeleton of. We didn't include too many things, too much information about each column. That's not really necessary. And like I said, if you can't use this, there's nothing that says we can't use this. But it's your work, it's your personal work. You can just get a pen and a paper and draw all of this the way you want to draw it. Okay. Do we have any question? I think
um, okay.
yeah, please go on.
Now, could you go back to that diagram? I just want to say something in 1 minute.
Okay.
Yeah. So like this diagram now is very, very explanatory because our focus is on the orders, right?
Yeah.
Orders, we are trying to measure we are trying to track. Okay, let me use tracking now. We
Yeah.
are trying to track our orders. And in order to track our orders, someone made orders.
Yeah.
So there are different types of customers that made orders.
Yeah.
It was made on different dates.
Yeah.
Different weeks, different months, different quarters, different years. So the dates, we capture that. There was a particular product that was ordered. Product A, product B, product C, product D, product E. There's an employee who processed those orders.
That's right.
There was a location. Is it in Europe? Is it in England, Amsterdam? That the orders were the orders were processed from? Then who shipped those things to the customers? You know, is it shipper Olamide or shipper Debbie or shipper Francis? Who shipped those things?
Yeah.
You know, so we can now when we are now analyzing the data, we can now say, okay, how many did we ship through Mr. Francis in 2022? How many did we ship? You know, is it increasing? Is the trend going up? Is it, and we can all use this to make informed decisions. Yeah, let me stop there for now. Yeah,
thank you. Thank you very much. Thank you. Yes, that's correct. That is very, very, I love the explanation, the further explanation you have given. And we can see even within this data set, it says order date, required date, ship date. We can easily track the order was required for a certain date. It was shipped at a certain date. Did we
Was it
do
late?
well?
Was it early?
Exactly. We can easily see what's happening and quickly make informed decisions before we lose customers.
If it's late, why is it late?
Exactly.
You know, we investigate, we can keep a track.
Do we need to change our shippers or what's holding them on the way? Is it the processing that was delayed? You know, so all of as much as possible when the data captured is really at the lowest of levels, one can get better insights, you know, into what is really happening within an event, within a place, or within a business. Thank you so much. Any question before we call it an evening?
Yeah,